It's so great to be back here at React Native EU after such a long time. So we're going to talk about lifting and shifting an ecosystem. Uh-oh. Okay. My name is Matt Hargett. I'm the founder of Rebecca Specialties. I've been on the stage a couple of times for a couple of different companies, but I thought I was going to retire in October, and then I had an idea that was going to bother me if I didn't go do it. So I'd founded a new company again. I'm on the Twitter, I refuse to say the other thing, and GitHub, and Threads, and I put most of my stuff on Threads these days. Assuming the Wi-Fi is working and that I can access it from my phone, if people want to go to the GitHub repo that we're going to be talking about today, I will, and dig through code and ask me some nerdy questions, I will open the Expensify app, and if the Wi-Fi is working, because the app is awesome, I will, if there's time at the end, I'll read some of those questions. So for those of you who weren't here 5 years ago, my name's Matt Hargett. I've been programming for a long time. I've been shipping products in Silicon Valley for a little over 25 years now. I met my husband in the year 2000. I deployed the first React app, my first React app at scale. And around 2013, I was CTO of a company where we deployed React. And that was a really cool technology at the time. Our child was born in 2015. And then I brought React Native to multiple new platforms starting in 2016 for the companies that I was working for at those times. And I recently founded my second company, Rebecca Specialties, like I said. So 5 years ago, I was on this stage in this venue talking about bringing React Native to the next billion devices. That was the name of the talk. And there was some chatter about billion devices, that's crazy, like there won't be that many iPhones. And people had a kind of a narrow concept of what React Native could do and where it could be deployed, I think. And so in 2016, partnering with Callstack and Microsoft, and Infinite Red, actually, we brought React Native to Windows 7 and 8, which was 350 million devices globally at that time. And you can go like, Windows sucks, but that's 300 million potentially paying users, especially in large enterprise. And then a few years later, working with Callstack and this .labs, we brought React Native to game consoles. Use your imagination. And then we started to see, I had nothing to do with tvOS or Android TV or the Amazon Fire Stick work, but we started to see apps shipping on those devices using React Native. Not just someone did a port to a platform and then nobody shipped anything on it, but high monetization of React Native on those platforms. And then we saw React Native being used on consumer electronic devices that are running Linux. And then we see it on macOS, thanks to Microsoft and other folks. And then I think we're going to see it pretty soon here on Vision OS as well. And then who knows where React Native will go to after 2023. So for some reason, when I was a teenager, I got really into the philosophy of Andy Warhol. You know, the idea of taking an iconographic person or image and using a silkscreen to replicate it. And I just really loved the duality of the idea of, well, it's so cheap to make to do a silkscreen, is that skill? And other things like, is that valuable? What is the value in that? And, you know, if you make 1,000 Elvises, does that make Elvis more valuable or less valuable? And this idea of fame as a commodity and the concept of overexposure. Is there such a thing as overexposure? So, with all the success of bringing React Native to all these other platforms and the high amount of user delight from really fast performant UIs, and then the amount of monetization as well. And we're all sharing lots of code, so the economics of it from a software development perspective are really great. How do we bring React Native to even more places? We can't just wait for Apple to ship new hardware every 5 years. What can we do? How can we get React Native into some of these legacy ecosystems? These $500 million, billion-dollar, trillion-dollar businesses where they don't have necessarily a brownfield native app today, or even a JavaScript penetration within their kind of enterprise, or new mediums. I'm not going to say the M word. I hate the M word, metaverse. But other just anything we can use our imagination about. Braille printers for the blind. There's all kinds of things that we could be using React and React Native for. And then fresh platforms, stuff that will be coming out next year, stuff that we can't even conceive of yet that companies are working on. And I think that one of the ways we can get React Native into even more places is to bring React Native to new languages. And in the past, there's been Reason, there's been other kinds of inroads to this, but I have a little bit of a different perspective on it. So first, I want to say, this is not about language advocacy. We're going to talk about a specific language. I'm not saying you should use that language. The business I was working for had a sunk cost, had a constraint in that language, and I had to work to the constraint. So I don't want anyone to, please don't come up to me later and go like, hey, that language you talked about is dumb. I don't care about that. And I'm not trying to convince you to, I'm not suggesting that anyone migrate away from JavaScript or TypeScript or toward any specific language. And I'm just here to tell you about how I created and executed on this strategy to great effect. Second framing around this is, this wasn't like a, hey, let's do the wackiest thing possible. Like, how can I do like just the wackiest off the wall thing possible? I was trying to solve a business efficiency problem and a product viability problem for a very, very large business. So this is all about positive product outcomes. And positive product outcomes in this case did have business uplift, as we'll talk about. So the kind of bottom line up front here is crashes got reduced by 90% by bringing React Native to this new language and then getting that out to 150 plus active million, not 150 users, 150 million active users. The frame rate doubled for those people across 5 different platforms. Logically, but also backed by data that increased engagement and increased monetization, because the app doesn't crash as much, so people stick around. And if they stick around longer, there's a greater chance that they're going to monetize. That's logical, but it was also backed by the data and analytics that we had. And then the other thing was, once it was that much more stable and it was that much more easy to write very performant features, feature velocity went up. More features to help increase engagement got shipped out faster and cheaper. And I hope it doesn't sound too trite, but happy users, less effort over time, and better business outcomes. So translating React to Lua. File by file, line by line, character by character. And I was just trying to figure out, how do we get that battle-tested code base into this ecosystem? I felt like that was the shortest path, but very high risk, potentially high risk. To me, when I started learning Lua, which I hadn't learned before, except when we were reverse engineering Grim Fandango for ScumVM 20 years ago, to me, I was like, these languages seem pretty close to each other, but a lot of diehard Lua people are like, no, 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 JavaScript is stupid and sucks, but Lua is so special and you have no idea. And I was like, they seem pretty close to me, so let's just try it. So we started at the leaf nodes of the dependency graph, and in React, that's the shared directory and the scheduler directory. And they don't really use any external dependencies at that level. We translated the implementation and the tests. Because we were doing the translation manually at first, we'll get to that a little bit later, I felt it was the most responsible thing to do was to bring the tests along for the ride so that we always knew that as we were translating things, it was compliant with the upstream tests. That meant we had to level up the testing frameworks that were available in Lua, which is good anyways. Upstream doesn't have tests for some key files relating to like error handling and kind of processing of stack traces, the text of the stack traces. And one of the reasons to use React 17 was to have all those great dev mode warnings that can tell you exactly the component name and exactly where that component was instantiated from. So that was really important. And then once we had tests translated and sort of running the scheduler, we were able to take that test, run it 1,000 times in a loop or 10 million times in a loop, and do wall clock time comparisons between Lua and JavaScript. And we'll talk about that in a second. And so we benchmarked that against Node.js running in jitless mode because the Lua runtime we were using didn't have a JIT. It was bytecode only. We could have used Node Chakra Core, I guess, but Node.js has this jitless mode now. And one of the coolest things, one of the coolest outcomes of this is nearly every time I went to the VM or the virtual machine or languages team at my previous company, and I said, hey, here's the Node.js for the same code, for this code, and then the same code transliterated to Lua. Here's the benchmark. Can this be faster? Almost every time I came to them with hard benchmarks, hard numbers, and humility, they almost always made the VM faster. And that made that Lua code faster for all the games on the platform, everybody. That was pretty awesome multiplier effect. If your target language, again, whatever language we want to talk about, but in Lua's case, we did have a strongly typed Lua, so we translated the strong types. What I found in that process was that React's own flow types are there and are a good basis for working from, but I found that we also had to pull from the TypeScript types indefinitely typed, but even those aren't super awesome when it comes to type checking. They're kind of more optimized for autocomplete than type safety. So then we also kind of Frankenstein together, pulled from the kind of JetBrains IDEs, have their own type definitions buried in them so that they can work even better than VS Code or Visual Studio. And the real takeaway here is translate each layer as you translate it. I'm sorry, verify each layer as you translate it. Bring over the tests, and if you don't have types, fine, you have the tests. Bring over the types if you can. But if you had to choose between the two, choose the tests. Types will not help you figure out that your promise reimplementation is broken in a very subtle way, but the React reconciler tests will. And this is not meant to be read. You can look at the slides later, but this is an example from the React shared directory of one of those kind of stack trace processing things that gives us great dev error messages that are really actionable, and the interface stays the same. The implementation is completely different on Lua, and would probably be completely different on another language. But then we have other files, like here's an example of profiler store from React DevTools, which we also translated into Lua, because DevTools are awesome, and the profiling is awesome. And pretty much line for line, it is 1-to-1. There's one difference here, and that is that where the lines get skewed slightly. And this particular file was translated by an automated tool that we eventually made, or this .labs eventually made. And that automated tool adds a comment to note to any future human looking at it that this is a different number here because Lua uses 1 based arrays, not 0 based arrays. And I'm sure to some, many, everybody, that sounds completely insane. But we did this in such a way that we were able to get a checkpoint every 2 weeks and go, is this working? Should we continue or should we bail? And a big influence on my thinking about these sort of things in general, because this isn't the first time we've done something, is there was this book I read in the late 1990s called How Would You Move Mount Fuji? And before Google ever existed, Microsoft was legendary for their coding interview puzzles, and one of them was how would you move Mount Fuji? And spoiler alert, but basically if you treat it like it's an excavation job and you go, what's the volume of rock? How many trucks can we move per day? Should we widen the road first? How much money do we have? What's our budget? What's our time frame? You just break it down like any other problem. And I think that one of the things I got out of this book, but also just from programming in the 80s, people conflate tedious and hard, and there's a difference. If you can be at peace with highly tedious, highly repetitive things, you can take a $500 million business and then add another 10% on top of that, as opposed to going like, well, that's hard. No, hard is we need new computer science. Hard is no sorting algorithm exists. Hard is, we need a self-modifying AI that can, become Skynet and whatever. That's hard. This stuff was just tedious. And if you can be at peace with tedium for a short amount of time, you can have incredible business uplift that more than pays for itself. So I said before, to me, I thought the languages were pretty close together. Some people disagreed, but we took it chunk by chunk with the tests passing. We had the first test passing in a couple of weeks. There were some hitches that was not foreseen by me. And one of them was React actually has, in the reconciler in particular, but also between shared and the React package itself, some circular dependencies and then some very interesting workarounds in the bundler scripts. And Lua couldn't tolerate that. So I should have put I tried to be gracious, but I did that work to kind of do that. And I really thought unless people look at React character by character, line by line, and get it to run, it's a kind of a barrier to entry for upstream React to get new contributors. This very interesting circular dependency tangled thing between the React fiber star.js files. So we, I'm gonna stop being gracious for a second. So I did the work to do that in the JavaScript as well and submitted a couple PRs and they're linked there. I did it all in one piece to show hey, this all fits together. This isn't just moving stuff around for no reason. We were able to remove the complicated bundler config whose whole purpose was to fool the bundler into not freaking out about the circular dependencies. And I did talk to Dan Abramov about it. We had a couple of video calls about it. And once he understood the intent and whatever, he was kind of verbally supportive. But unfortunately, we couldn't get the rest of the people that were on the React team at that time at Meta to merge the PR. I still think that's really good work. That would help lower the barrier to entry for maintainership. And I think that a lot of the work in React Native, even over the last 2 years, to similarly make it more welcoming, which is kind of a vague word, but there's a bunch of stuff that happened to make it more approachable for a lot of people. I think that would be a good thing in React as well. Lua doesn't support putting instance fields on functions, so with function components and hooks, parts of the reconciler would put a property onto a function, and while Lua supports first-class functions, it doesn't support putting fields on them. And when we saw that, I was like, oh, this is it. This is the stopping point. But hey, if we just reuse the scheduler and shared, we're still coming out ahead. But we were like, well, how bad would it be if we just didn't do that? So we didn't do that, but we didn't know how it was going to play out until we had the end-to-end app running and started purposefully generating errors to see what the stack traces looked like, what the dev mode output looked like with those function components. And it was fine. But it did make us nervous when we thought that would be the problem. And then another thing is Lua's garbage collector can be sensitive, and I would say any new language you're porting to whose garbage collector isn't incremental and isn't compacting, React has several places in the hot path of stuff it's doing all the time, no matter what kind of app or components that you have, that rapidly create short-lived objects. I implemented a simple memory kind of object pool where it just recycled the update objects, for instance, and that solved our problem. That might be a good thing to upstream because, yes, the GC will take care of it, but how about you just give the GC less work? It might lead to better battery life or performance. And if your target language doesn't have a kind of a Babel transpiler sort of thing, there's a couple of places where we had to kind of do that old school, like before there was dependency injection frameworks in Java. What did you do? You just added a parameter and you passed the thing in. That's what we had to do in a few places. So there's some tests in the reconciler and elsewhere that kind of rely on a fake console being injected so that when output happens, it gets buffered and you can assert that the right dev output happened. So we had to solve for that in kind of a manual injection sort of way. And then the other one is there's a couple of config files. There's the React host fiber config and some other stuff. And instead of those being remapped dynamically at bundle time, we just explicitly pass them in to parameterize the require, so that when you require some of these modules, you pass in the host config you want it to use. And versus upstream, which just returns you the exports, we return a function that accepts that parameter, and then the return value of that function is the exports. This is all on github.com/js.dotlua, by the way. So some foreseen, some unforeseen, but there were no blockers ultimately. And render to what? So in this case, we were talking about a legacy game engine that had been around for 16 years. It had thousands and thousands of games written in it. So that was not changing. The UGC compatibility was a fundamental, unmovable sort of thing. What I would say is that before you think about your own render, I would definitely recommend porting the no-op renderer and the test renderer both. Test renderer is used by your non-framework developers to be able to render stuff quickly and without a DOM or without a game engine or whatever. That was really important. And the no-op render is used heavily in the reconciler tests. And it turned out to be super smart to have the no-op renderer so we could do those tests. Those tests found all kinds of subtle bugs in bugs in our translation of suspense, for instance, and hooks were particularly tricky in terms of ported logic. Let's see. Yeah, and we use the React Native renderer as the basis for the new renderer. It's a sort of out-of-tree renderer, but there's not, at that time in 2020, there wasn't an explicit renderer interface, but you can look across a bunch of disparate things and piece it together, and that's what we did. And we put most of our deviation, custom rendering logic into the renderer. Don't go just modifying the reconciler. And it's not a knock against the reconciler. What it does is complicated. There's a lot of config options and branches. Don't mess with that code if you don't have to. Would be my recommendation. Benchmarking. So as soon as the scheduler tests were passing, we benchmarked against Node.js. Every time we did that, we had a new layer translated with some tests. We just took the tests, ran them 10 million times, and then asked the VMware languages team to make it faster. And it wasn't that it beat Node.js jitless in the end or anything like that, just can it be faster? The answer was usually yes, and they were fantastic partners on that by being data-driven. Once the full game engine renderer was complete, we benchmarked on device, the lower-end devices that we saw out based on our telemetry, and we did time to first paint, time to interactive, and time to fresh data. And doing that off device, even capturing video on a low-end device, you're drawing battery, that takes TDP away from the SoC. Don't do that. Just you have a 120 hertz camera on your phone like most people do. Just record that and then scrobble it. And that, for our purposes, was enough to show how incredibly much faster React was. And then we did that for both cold app start and for deep links. Cold app start looked good, but then some deep links didn't, and we had more work to do in terms of optimization. Deployment. So I wanted to do a phased deployment. We were making a big change. We're changing the engine of the plane while it's in flight and running. And we had to build a phased deployment pipeline because that didn't exist yet. And I would suspect that in some legacy businesses, that would be the case. But that allowed us to then go to 0.1% on one platform. Does it look okay? Go to the next. And across at least 4 platforms, actually more, but I'm not going to list the other ones. And then monitoring. So in terms of Is it crashing? What is monetization doing? Some of those dashboards existed. We had great partners on the data science team for some of that stuff, but when it came to crash reporting, we actually had to enhance the crash reporting of the platform itself so that we could be sure we had the visibility. And as part of deploying it and then just like staring at, it wasn't Bugsnag, it was something else, the kind of crash reporting, I looked at hundreds of stack traces a day that had, some of which had nothing to do with us. That was really educational and teed up some work later. And it was a success. After we deployed to 0.1%, saw some crash, pulled it back, fixed a bug, and then deployed it. And then after that point, it slowly ramped up over the course of about 4 or 6 weeks. And that ramp directly correlated with increased engagement, session times, and monetization. And it immediately cut, when we were deployed to 100%, it cut the total stack trace volume, the total crash volume, by 50%, 50%, cut in half. And that's what you get when you port a battle-hardened code base. Scaling the uplift, there was a question where it's like, we had to enhance a testing framework, and at some point I was like, should we just port Jest? And people were like, sure, but who's gonna do it? And we found an internal team who that was within their remit, and they ported Jest. So they took our documentation that we made about how to port stuff from JavaScript into Lua, and they recreated that with great success. That was awesome, because then everybody got the awesome Jest matchers and the awesome Jest output. It was fantastic. And then the question was, well, can we parallelize this with an external team? The internal teams were all staffed for other things. And the answer was yes. So we hired this.labs, who was a partner on other React Native stuff, and they ported GraphQL manually, character by character, line by line, which GraphQL is a lot smaller than React, and dare I say simpler than React. So, but still, we proved it can be done on time and on budget with an external resource. And after that, my question was, like, thinking about Andy and the silk screens, how much of this can we automate? Open question. This.labs made a transpiler that was then used to dramatically accelerate the port of the Apollo GraphQL client, which was a lot of very complicated code. Then the question was, okay, we can automate the initial conversion, and then there's some manual tweaks that happen, and we make sure all the tests pass. But then, can we automate the majority of the upgrades? If we just port it once and then it dies on the vine, that's valuable, but not as awesome as it could be. Can we automate this upgrade? So we monitor the upstream repo, they do a release, we translate that to Lua, we make a diff, we apply the diff. It's actually it's not too dissimilar from the upgrade helper for React Native. Yes. And 85% of the upgrade from just 27 in Lua to just 28 in Lua didn't require human intervention other than to click the merge button. So repeatable, scalable, durable, and then cheap. All the things I like in that order. And then they lived happily ever after. And isn't that, wait, what? Oh, what about React Native? I'm sorry. I totally forgot. This is a React Native conference. So when we were doing our monitoring as we were deploying React out to 150 plus million active users, I saw trends in the stack traces and got kind of a mental inventory of other problematic areas that we needed to address. And one of them was the list components. The next largest source of instability were these scrolling list components. And me being me, I was like, we have React and Lua now. How hard would it be to port flat lists, which we used to great effect at the previous company. And the Cliff's notes on this is that the API stayed consistent. We just added like 1 or 2 extra props. And when I say we, I had nothing to do with it other than posing the question. One of my colleagues, Henry, actually did all the work. He was awesome. He used the JS to Lua tool to accelerate the front end of it. While the API, the public API stayed consistent, the implementation did dramatically change. But it was still a very good basis. It required more end-to-end tests and mocking than upstream React Native had done to that point. That's probably good stuff to upstream, maybe. Even though it required deeper customization, the automated upgrade from 68 to 70 was still extremely smooth. using those automated toolings. We did the benchmarking on device. We replaced one list instance at a time. We were able to get even more fine-grained. That reduced the overall crash volume, which was already cut in half, by another 80%. And there was less than 10 bugs found between QA and production. There were some bugs that did exist that were kind of rare corner cases, but they were quickly fixed. Henry was awesome about writing tests. And that was a success. Again, more social and search engagement where the lists were being used, longer session times, more premium feeling app, a lot less jank. So that worked great. Can we bring Lua to other platforms? Yes. NeoVim uses Lua, Nmap uses Lua, OpenResty uses Lua, World of Warcraft, et cetera, et cetera. And Dark Lua is an open source compiler, or transpiler that can really help with this stuff. It just needs some additional features. So the other thing we're going to talk about is Playdate. Let's see. Here we go. And here we go. You want to zoom in a little bit? Whoop. Playdate is a cute little console that had a Kickstarter, and it has a crank. And it's not quite coming through. I'll show it in the simulator. This is Jest running some React DevTools tests, and that's the test output and I made one of the tests fail on purpose just so we could see what that would look like on the test failure. And so again, I'm not here to advocate for Lua necessarily. I wouldn't use it for new projects, but there are things that ship with Lua, and once you bring Jest to it, you can do more cool stuff. Once you bring React to it, you can do cool stuff. The demo stuff I did, I manually translated the requires because the automated tool doesn't exist for Playdate, for the Lua Playdate. What's next? My time with Lua is coming to an end. I wanted to commoditize my knowledge, which I'm here doing right now. Thank you for listening. And it'd be nice to contribute relevant changes upstream, like I said. The Dark Lua tool has several issues that we have identified that would make it even more automated, but the maintainer just needs funding. They are available for contracting, they just need funding. The JS to Lua tool that this.labs created for us is not open source, sadly, but I think a 2.0 rewrite would be a cool thing to fund. And the Lua community, the Lua community is voracious. They ripped apart the bundle. That's why all that stuff got open source, because it was all MIT derived. But that Lua community is already porting more JS now that they know how easy it is. And one really cool thing that is very topical, it turns out, for this conference is that this person in the UK, Brooke, she ported the Sentry client so that Sentry gets these awesome Lua stack traces, which is cool. I would love to see this repeated for Verse, which is Epic's scripting language for Fortnite. I think this could be done for other languages as well. And then everybody can have their own Elvis. Thanks, everybody.